Hello, this is Dan with College Technologies. I just wanted to kind of go through something real quick here to kind of describe and illustrate the best way to find out if Wi-Fi interference is causing issues for your network connection. One thing that anyone can do that's got a Windows computer is they can basically go and download this program called Wi-Fi Analytics. So we're going to go ahead and open that up right here. When you open it up, you immediately see that it'll start listing some networks. The SSID is going to be the name of your network, or network name as most people call it. And basically that will just show you each network that is within your range of the laptop that you are using for a Wi-Fi analytics tool. Okay, a couple of things to keep in mind. First, obviously we have our network name, and then if you go over here, you have the channel. Channels can be very important. We'll get to that in a minute. To determine the best channel for your network, you'll have to kind of use this tool to go ahead and make the necessary adjustments. So as we can see here, College, which is the network that I'm running, is on channel 11. This Netgear 24G would be one of our neighbors' networks. They're running on channel 1. Okay. The next thing we have here is what's known as the RSSI. Think of it as signal strength for the most part. And you want to get as close as you possibly can to 1. So basically, if you look at negative 52, obviously is a greater number than negative 88, which indicates that that is a better signal strength. Typically speaking, you want to have your signal strength to be at negative 70 or higher. So obviously negative 50 falls within that range, so that's fine. The next tab that we look at is the security tab. Both of these networks are utilizing WPA2 personal. WPA2 is the most secure encryption method available for Wi-Fi networks today. WEP is very easy to crack. People without any skill set at all in hacking can easily crack a WEP encrypted network. So I always suggest to use WPA, or even better, use WPA2. So now we get to our next tab, which is the MAC address. The MAC address is going to be the actual, think of it as a serial number for the Wi-Fi adapter on that particular device. Each computer, each Wi-Fi adapter in each laptop or desktop or whatnot, tablet, iPhone, will all have its unique MAC address. So what we see here is the MAC address for the College network, and then of course the MAC address for the Netgear 24G network. Next tab is pretty self-explanatory. It shows you the max rate. This is in terms of megabits per second. So what it does is it calculates the signal strength combined with what type of a network adapter you have. Both of these network adapters are going to be wireless N. Even though this says 24G, that's more than likely for 2.4 gigahertz, but not for wireless G. It's going to be for the 802.11n standard, which is pretty much the standard that is available today. That's most commonplace. It deals with the 802.11n standard is also known as dual chain, a dual RF chain, a much more secure, stable, and fast way to connect versus 802.11g, which has a max rate of only 54 megabits per second. And of course, you can see here, another network just came up here. More than likely just somebody driving past, but they're on channel 6. Okay, nonetheless, what we see here is the vendor of the particular router. Well, the way that the vendor is determined is by the first 6 characters of the MAC ID. Each vendor has specific characters, so we can tell that this is a Netgear. Both of these are, and then of course this will be a Novotel wireless card within this MAC ID here. Network type, you have 2 options, 2 basic options. The first being infrastructure, and then there's also one known as ad hoc. Most of your wireless devices are going to have what's known as an infrastructure network type, which means they operate as access points and/or repeaters whereas an ad hoc would be something like a printer, possibly some other devices, that kind of stuff. But if you'd like to maintain a network connection, typically you're going to look for infrastructure. That's what we'll deal with today. So this tool that we have here is called Wi-Fi Analytics Tool, this software program. You can download this, go to Google and download Wi-Fi Analytics Tool, or you can also download Insider, INSSIDER. That's the engine that's actually running this Wi-Fi Analytics Tool, and it was produced by MetaGeek, which is kind of at the forefront as far as companies are concerned for Wi-Fi analyzation. They have a lot of different products out there, but this is the one that is most commonly used. Basically, this just takes into consideration your Wi-Fi networks. It does not give you insight into all the different devices that are available in the 2.4 gigahertz range. So if you want to see what's affecting your networks in terms of Wi-Fi, this is what you would do. But it doesn't give you the complete picture, only gives you Wi-Fi and not things such as your Bluetooth, which does affect your wireless connection, cordless phones, baby monitors, wireless keyboards, stuff like that. All of them do have an effect on your network connection. All right, so we're going to go ahead and go to the channels. If you notice, there's channel 11, channel 1, and channel 6. These are known as the 3 non-overlapping channels. Even though in the 2.4 gigahertz range, which is what most laptops and network devices use to connect today, even though there's 11 channels, there's only 3 that are non-overlapping. And let me show you. So we go to 2.4 gigahertz channels, and this one is not even showing up, barely. But anyhow, let's look at the Kalashay network. It's on channel 11. What I mean by an overlapping channel is basically that if you see channel 11 overlaps into channel 10 and channel 9, 12, and 13. 12 and 13 are not choices that you can make in the US here, but we do utilize portions of those channel bandwidths to make a connection in 11. You also notice channel 1 overlaps into channel 3. And if we had channel 6 here, it would overlap into channel 4, 5, 6, 7, and possibly 8 as well. So that's why these are the 3 non-overlapping channels. The reason being is that the frequency of the 2.4 gigahertz range, each channel has a width of 22 megahertz. And so they didn't really give us, when they decided to give us these channels, they didn't give us enough to make them non-overlapping. Just to give you an idea, not that this laptop has a 5 gigahertz adapter on it, but all of these channels in 5 gigahertz are non-overlapping. So if you were to choose, say, channel 36, you would not overlap into channel 40 or 44, and so on and so forth. But that's for a discussion at another time. So we're back here on channel 11 here with Kalashay. And then also the Netgear that keeps coming in and out, and you'll see it's got a very low signal strength, very, very low. So that's why we see it coming in and out. Typically speaking, when it comes to signal strength, like I said, you want to have something that's negative 70 or better, because then you will start to have issues with packet loss, dropped connections, slow connections, so on and so forth. All right, so let's take a look at the time graph. Now, time graph is showing, for the most part, that the Kalashay network has maintained an even signal strength of negative 50. What that indicates to me is that there's not really anything affecting it as far as interference goes. Wireless or Wi-Fi is known as a contentious medium, which means that at any given time, only one device can transmit at a time. So if you have 2 adapters within the same vicinity, say the Netgear and the Kalashay, that were on the same channel, that were trying to broadcast or transmit at the same time, what would happen would be what's known as packet collision. The packet would then be lost, and then, because the Wi-Fi adapter did not get a response back that the laptop did receive that packet, it would then send it out again. Obviously, having to do the same thing twice slows things down, so that's where your interference starts to affect your connection. Too much interference, you have no connection, spotty connections, so on and so forth. The reason why this becomes important is because there's 2 things that you deal with when you're talking about a wireless connection. Most people at least. You're dealing with the bandwidth of that connection, the max rate of 144, and also latency. Latency is how long it takes for a packet to be sent from point A to point B. Obviously, that's going to determine speed. Your bandwidth is going to be what determines the size of the pipe. Think of it as, in terms of plumbing, you have a large pipe of water. That would be, or a large water pipe rather. That's this max rate of 144. Think of the latency as the pressure. If you've got higher pressure, it moves more packets or more water through that pipe and more gets there faster. If you've got a smaller pipe, more it gets there faster, but maybe not as much as you'd like. So ideally you want to have a low latency, somewhere close to like 10, 20, 30 milliseconds. With wireless, 50 milliseconds is not uncommon in noisy environments. And you also want to have a high capacity in your bandwidth. Now, I'm glad that this just happened here. You notice this little dip here. But you'll also notice that, like I said, these three channels are not overlapping. So the likelihood of this signal right here, the Netgear 24, affecting this channel is not a possibility. There is something else. However, because we're only using a Wi-Fi analyzer, we can't see what that would be. With a spectrum analyzer, a 2.4 gigahertz spectrum analyzer, we could see that maybe that there was a Bluetooth device that all of a sudden affected the connection and so it dropped out. It could be a baby monitor, many devices. All of our wireless devices operate in some fashion in the spectrum. So this is important to keep in mind. So when you're dealing with wireless connections that are shoddy, that are slow, the first thing you typically want to look at necessarily is the spectrum itself or the Wi-Fi itself. You want to see if there's other networks in the same area. If you see that there's multiple channels or multiple networks on, say, channel 6, and your network's on channel 6, you might just want to switch to channel 1 or channel 11 and find one that's the least congested. The amount of difference that it makes in your connection is substantial, especially when you're dealing with noisy environments. Fortunately for me, this is not a noisy environment. However, if it was, you would see a lot more of this going up and down. It would look like a heartbeat monitor almost, than you would a nice straight line. That's something to keep in mind when you're dealing with very congested areas such as apartment complexes or very urban settings. You want to take a look at that and find the channel that's got the least amount of congestion, that's not overlapping. If there's a bunch of networks that are on channel 10, switching a network from channel 6 to channel 11 is probably going to give you less of a stable connection than if you found something that was further away due to the overlapping nature of the channels, as you can see. So this was just a real quick tutorial on how to determine wireless or Wi-Fi interference. Like I said, this is just a small portion of what actually occurs. To get a better understanding or a better picture of what actually occurs, you would want to have a Wi-Fi engineer come with a spectrum analyzer and take a look at the entire environment around. And keep in mind that while we're taking this reading right here, this is only the reading from my laptop. This is not the reading from the access point. So to get a clear picture, you'd want to go ahead and take this reading where you'd like to connect your laptop from, and then also the reading right next to your access point as well. My name is Dan Robeson. I hope that this was helpful for you, and if you have any questions, please feel free to contact Coloshay Technologies. You can visit our website at www.coloshay.com. You can email us at sales@coloshay.com, or you can give us a call at 1-800-592-1196. Thank you very much and have a wonderful day.